Students, let us solve the JEE chemistry question paper, So, which was held in the month of July 2021. Let us start part B, chemistry, section A. So, 20 multiple choice questions we'll discuss, and each question has 4 options. Out of 4 options, we should pick up only one option. Correct option we have to pick up from this question paper. Let us start a discussion of questions. So, first question. Here, the first question is chemical nature of the nitrogen oxide. Chemical nature of the nitrogen oxide compound obtained from a reaction of concentrated nitric acid. And the P4O10 4:1 ratio is. The question is given the chemical nature of nitrogen oxide. So we should find out chemical nature of nitrogen oxide compound obtained from the reaction of concentrated nitric acid. So what is that oxide of nitrogen? Then its nature we should write. The reaction between nitric acid HNO3 plus P4O10. P4O10 is the anhydrate of phosphoric acid. So this is the anhydrate of phosphoric acid. When this nitric acid reacted with this P2 oxide of phosphorus, so what happened means, so I mentioned the question 4:1 ratio, 4:4 moles versus 1 mole ratio. So the concentrated nitric acid react with P4O10 produces anhydride of nitric acid N2O5 plus we get HPO3 taken 4 times. That means we can get N2O5. N2O5 basically is acidic in nature. N2O5 is anhydride of nitric acid. So then so we can get N2O5 which is acidic in nature. Then so N2O5, so acidic in nature, D is the correct option. If it is NO, N2O, so particularly N2O, neutral, but it is not neutral one, amphoteric, so no amphoteric in this, no basic. So here eliminate these 3 options, and acidic is the most appropriate answer for this question. Let us move to second question. The compound A is converted to B. So compound A is converted into B on reaction with CHCl3 chloroform and KOH. So A compound is treated with CHCl3 plus KOH. So we get the compound B compound we get. So A changes into the B, and the compound B is a toxic. B is toxic mentioned here. Toxic is mentioned and can be decomposed by C. So it is decomposed. So the toxic can be decomposed by C. So C decomposed by C. So A, B, C means we should find out A compound, we should find out B compound and C compound from this. So now let us see A compound react with the chloroform and KOH. So chloroform, KOH, and the toxic compound that. So definitely A compound is 1 degree amine. 1 degree amine, primary amine. You can take RNH2. You can take plus chloroform CHCl3 plus KOH. So so upon just mild heating, we can get when chloroform and KOH react with this amine, primary amine, we get that compound RNC isocyanate. This is amine. Primary amine changes into isonitrile compound, which is toxic, which is so obnoxious compound. This is toxic compound isonitrile. So this itronite, since it is a toxic, it can be neutralized by so acidic medium. So aqueous solution of HCl. Then we can get again amine. We can get NH2. We can get plus. So C formic acid. We can get formic acid. We can get. That means here the compound is primary amine isonitrile compound concentrated HCl. So here is the B is the correct option. Correct option. So primary amine nitrile compound concentrated. Nitrile means so it is not toxic. Isonitrile is a toxic. Secondary amine is doesn't give isocyanate test. So with any OH. So nitrile. So these are options are can be eliminated, and the first also can be eliminated. The most appropriate answer is B answer, primary amine isonitrile compound concentrated HCl. So this is the most appropriate answer so for this question. Now question number 3. Given below are two statements. One is labeled as assertion. Given below are two statements. One is labeled as assertion, other is labeled reason. So assertion, the dihedral angle in H2O2. So H2O2 is the shape of this H2O2 is it has open book shape. Hydrogen peroxide has open book shape. Open book shape. So it has open book shape. It has open book shape. And what is mentioned here, dihedral angle. Dihedral angle in H2O2 in gaseous phase, it is given, for example, in gas phase, how much is given? 90, so 0.22 degrees given. In solid phase, it is mentioned, the solid phase, in solid phase mentioned how much it is 0.5 degrees it is mentioned. The solid phase 111 degrees is given, and solid phase, and in the gas phase, so it is given how much. The reason mentioned here, so what is the reason is that reason is given. The change in dihedral angle in solid and the gas phase is due to the difference in intermolecular forces. Different in intermolecular forces. So, and difference in the intermolecular forces. So, and from this, what option is A is correct, and but R is not correct. A and R are correct, but R is not correct explanation. So, and here is both A and R are correct. R is correct explanation of A. A is not correct, but R is correct. Here is generally the angle, dihedral angle. So in gas and solid depends upon intermolecular forces. So that means in solids, intermolecular forces are strong. If the intermolecular forces are strong, then definitely dihedral angle should be less. It should be less. Should be less. In gas, it should be more. That means the solid phase dihedral angle is 111 should be in the gas. The dihedral angle in the given gas will be, it should be to the side. That means it is given reverse. Reverse. That means assertion statement is wrong. Assertion statement is wrong. So assertion is wrong, not correct. The change in dihedral angle in solid and gas phase due to the difference in intermolecular forces. It is absolutely right. So D is the appropriate answer for this question. A is not correct, but R is the correct answer. Let us move for the fourth question now. The fourth question is, the fourth question, what the fourth question is given here, you can see among the four options, among the given species, the resonance stabilized carbocation. So let us look into that resonance stabilized carbocations. What are that? Number one is, yeah, let me take. This is benzylic. The benzylic cation stabilization. So here is the carbocation is, so the pi electrons will go outside, then resonance. So it can be stabilized. So here resonance forms we can get. So stability due to resonance. Due to resonance. Resonance is possible. It can be stabilized. And number two, so number two here is a double bond. So here there can be double bond can shift to this carbon, and here is the positive charge. So there is resonance. In this also resonance is possible. Resonance stability is possible in this second option also. Now in this we can see here is the double bond. Here is CH2. Here carbocation. So carbocation stability, and this is allylic structure. Allylic structure. Resonance is not possible here. So stability is not possible in this case. So, and one more we can see here, and one more here. Here is the ketone functional group, and here is double bond CH2. Now, so, and in this case, if you think that if the oxygen goes, and here also resonance is not possible. Resonance is not possible in this case. We can go for the B option, C and D options we can go. Resonance is not possible. These cannot be stabilized. Not stabilized. Not stabilized by resonance. Now question number 5. A S-block element react with oxygen to form an oxide of the formula MO2. S-block element. So react with oxygen to form an oxide of the formula MO2. The oxide, the pale yellow in color, paramagnetic. So S block elements, two types are there: alkaline are present. Alkaline are present. So alkali elements can form oxides, peroxides, and superoxides they can form. Superoxides they can form. And alkalis also form oxides, but their oxide formula is MO, and here is oxide formula is Na2O or M2O formula in case of alkali. Peroxide will be M2O2 formula. So peroxide is not possible, M2 is not possible, and only MO2, so superoxide formula is possible. And that two superoxides having paramagnetic nature. So that superoxide KO2, RbO2 can form the superoxides, and there here is the potassium option is given. Potassium will form the paramagnetic, pale yellow in color. The B is most appropriate answer in this for this question. The question number six. So the question number 6, let us look into this. Green chemistry in day-to-day life is in the use of chlorine for bleaching of paper, chlorine. So for bleaching paper, large amount of water alone for washing of clothes, liquefied CO2 for dry cleaning of clothes, tetrachloroethane for laundry. See, in green chemistry, green chemistry in day-to-day life is in the use of. So chlorine for bleaching is not suggestible. Large amount of water alone for washing, so cleaning is not done properly. Liquefied CO2 for dry cleaning clothes. So recently, it has been started. Liquefied CO2 for dry cleaning is a good method, and so this is not harmful, and it doesn't cause a pollution. Tetrachloroethene for laundry causes pollution, and so most appropriate one is C, and the CO2 means liquefied CO2 for dry cleaning cloths we use. For dry cleaning cloths we use. Now, question number 7, identify the incorrect statement from the following. Beta glycosidic linkage makes cellulose a polymer. Okay, right. Amylose is a branched chain polymer of glucose. It is wrong. Amylase is not a branched one. It is unbranched. It is unbranched, we say. Unbranched, we say. Amylose. And starch is a polymer of alpha D glucose, right? Glycogen is animal starch. So B is most appropriate one. That means incorrect statement. B is the right answer. B is the correct answer here. Now question number 8, if we go, the metal that can be purified economically by fractional distillation method is, nickel, copper, iron, zinc. So generally nickel, iron, copper have high melting point and boiling points they have. But zinc has boiling point, melting point and boiling point is less. So the most appropriate answer is zinc is the right answer. The set in which compounds have different natures. So A, BOH3 and AlO4 OH taken to aluminum hydroxide, boric hydroxide. And boric hydroxide, or boric acid we can use. Boric acid we say as H3PO3. So have different nature. So any of which calcium hydroxide. So both are bases. And beryllium hydroxide, aluminum hydroxide, both having amphoteric property and basic also similarities there. Boric acid and aluminum hydroxide. So here aluminum hydroxide is basic, so basic, and boric acid has that acidic property, weak acid property, ability to release H plus ion also. It is quite different. And here boric acid and both are acidic, so property both having. So that's why, and these are not different. This is not different, and C also not different, but A is different. Ninth answer is A. We can select. The question number 10. The conditions given below are in the context of observing Tyndall effect in colloidal solution. The diameter of colloidal particle is comparable to the wavelength of light used. Okay. The diameter of the colloidal particle is much smaller than the wavelength of light used, so this is not relevant. The diameter of the colloidal particle is much larger than the wavelength of light used, so this is not appropriate. The refractive indices of the dispersed phase and dispersed medium are comparable. So comparable. The dispersed phase has very different refractive index from the dispersion medium. So here is the dispersed phase has one more last option. Dispersed phase has very different refractive index from the dispersed medium. And so we can look into the option is refractive indices. Indices are dispersed phase and dispersed medium are comparable. So we can go for this AD option, A option, we can tick for this. Now the question is question number 11. According to the valence bond theory, hybridization of the central metal atom is dsp2. For which of the following is correct? So here is the compounds are given. What compounds are given here is that A is K2 NiCN taken 4 times. So tetracyanonickelate potassium is given. Potassium tetracyanonickelate is given, and in this, so nickel plus 2 oxidation state, what the valence bond theory hybridization central metal atom dsp2 hybridization. Now let us look into this. Nickel 28, so out of 28 2 electrons are removed, so 3d8 4s2 is a ground state configuration, and 3d8 so 4s0, and in the d orbital, so we have to write 1 2 3 4, so 1 2 3 4 5 6 7 8. Since the ligand, what kind of ligand here is 4s and here is 4p, and what kind of ligand it is? Cyanide ligand is present. When cyanide ligand is strong ligand, we say strong ligand. And since the strong ligand, what it can cause? It can cause the pairing of electrons here. So then electron is paired here. So here electron will be paired up, right? So here when this electron is paired here, an electron is paired, and here this is empty now. So d orbital is empty. So d orbital, and here is s orbital 4s and 3d, and so 4p orbital is empty. So 2 p orbitals, 1 s orbital, 1 d orbital. So then we can write dsp to hybridization. It undergo dsp hybridization. We can write hybridization. DSP hybridization, DSP2 hybridization, square planar we can get. So this is option A. And if you take so nickel, so 6H2O means here H2O, if you write 6 taken times 6 times, so here is octahedral geometry sp3d2 hybridization. So octahedral geometry, this is octahedral geometry, we say octahedral geometry. Octahedral geometry, this is octahedral geometry, and this is nickel tetrachloride. Nickel tetrachloride, high spin complex, no pairing of electrons here. So hybridization will be so sp3 hybridization, tetrahedral hybridization, we say tetrahedral hybridization, because s orbital and so p orbital will take part. This is tetrahedral, we say, and nickel, so carbonyl, this also tetrahedral. So here this is tetrahedral and this is tetrahedral, and so it is octahedral. Now right option is A option is the most appropriate one. Now let us move for that next question. The question number 12. In the given reaction, 3-bromo, 2,2 dimethyl butane. So here is 1, 2, 3, 4. So butane. So 2,2 dimethyl. Here is a methyl group, and here is the methyl group is given 2,2 dimethyl. 3-bromo, bromine is mentioned here. And this compound is treated with C2H5OH. So then A compound we can get major product. So what is a major product? So we should answer here. And so here is the when this alkyl halide react with this ethanol, then the bromine, so the bromine means here between this, so C2H5OH, there is the bromine, the nucleophile attack this proton, then H plus is removed, then C2H5 behave like nucleophile. So then Br will depart and combine with HBr is produced. HBr is produced here. Okay. Then when the Br nucleophile take out this proton and electrons, then carbon will get the positive charge. Carbocation is formed here. Carbocation is formed. There is a rearrangement process. Methyl shift takes place here because 3-degree carbon is more stable. Then we can get 1, 2. Here is methyl shift takes place here. Methyl shift is happening here. Here is the positive charge. Here is the methyl group is there. Now the nucleophile attacks here. So C2H5O will attack this carbocation and will form the compound is CH3, C and CH3. So here is the methyl group, and here will be the C2H5. So ethoxy, 2-ethoxy and 2-methyl and 3. So 1, 2, 3, 4. So then A answer is most appropriate one. A answer is correct option, we can say. The Orlan fibers are made up of polyamide cellulose polyacryl nitrile. So P is the most appropriate because CH2 double bond CHCN. So this is nitrile group. So and acryl. This is that compound. So when n number, if you take n number of molecules subject to polymerization, we can get CHCCN. So we can write taken how much means n number. So this is a polyacryl nitrile, we say. So this is a monomer. Acryl nitrile is the monomer. So polyacryl nitrile. So this is a polymer, we say polymer. This is the polymer, and monomer is a acryl nitrile. Right. Now the question number 14th. We'll move to the question number 14th. The question number, the species given below does not show disproportionate reaction. So what is a disproportionate reaction? Means that means the same compound or element should undergo redox reaction. Means it should undergo oxidation as well as reduction. Redox reaction, we say. That means here in this, the species given below does not show disproportionate reaction. Disproportionate reaction, here is BRO minus, and so oxidation state, if you look here is +1, and here is +5 and +7 here, and here is how much means +3. That means here highest BrO4 minus. So oxidation state of the bromine is +7, highest oxidation state. So since the highest oxidation state of the bromine, that means so highest oxidation state only oxidized already. So that's why here is a BrO4 doesn't undergo disproportionate, because the bromine highest oxidation number is +7, so does not undergo disproportionate reaction. Now question number 15th. If you look into this question number 15th, so what is the question is given, the compound is given, alkene is, cycloalkene is given. The cyclic, so here is alkene is given, double bond is here, unsaturated alkene is given here, cyclic compound, and treated with this KMnO4, and H2SO4, treating upon heating. See here, KMnO4 is oxidizing agent we say, and H2SO4, and H2SO4 can facilitate and increase the oxidizing property vigorously in the presence of concentrated sulfuric acid. So when we use concentrated sulfuric acid in the presence of oxidizing agent KMnO4, so reaction is vigorous, then breaking of this bond takes place. As a result of this, so what we can see here is that since the bond is broken, in the presence of concentrated sulfuric acid, double bond can break up and it can form into COOH, it can form COH, dicarboxylic acid, it can form dicarboxylic acid, it can form because of concentrated sulfuric acid. So affect this reaction, and again the same compound when treated with this so KMnO4 oxidizing agent, instead of acid, what is taken? Neutral media, 273 Kelvin temperature is less, and water medium, reaction is mild, we say reaction is mild and slow. Slow also we can write, and here the oxidation takes place at the double bond, and so it can form diol compound, it can form 1,2 diol compound, it can form diols. So then what is the most appropriate answer is here, that means B, a compound A dicarboxylic and compound B is diol. B is the most appropriate. Okay, now 16th question. The 16th question, what is given here? Let us see. The 16th question is an inorganic compound. So the compound X is inorganic compound. Treatment with concentrated sulfuric acid. Treatment with concentrated sulfuric acid produces brown fumes. So brown fumes might be NO2 gas. Because of NO2 gas, brown fumes, dark brown ring, and and gives dark brown ring with the ferrous sulfate. So generally means with ferrous sulfate and concentrated sulfuric acid H2SO4, it gives brown ring. So brown ring test. So brown ring test giving compound is nitrate salt, nitrate, and nitrate salt upon heating, metal nitrate salt upon heating, it will give reddish brown color gas NO2. So metal nitrate. Concentrate. Also compound X gives precipitate with Y. This metal nitrate will give precipitate Y, and when in the presence of HCl and H2S gas. So H2S gas, HCl, metal nitrate will give the precipitate. PPT it will give. And so PPT, treatment with concentrated nitric acid. And when this PPT is treated with concentrated nitric acid, and excess of ammonium hydroxide, it gives a deep blue colored solution. So what is the compound X? So definitely, so that compound, blue color compound is so tetraamine copper sulfate solution. This is our nitrate solution. So here X is the nitrate salt. That nitrate salt we should look. Cupric nitrate is given option, most appropriate. Cobalt nitrate. The cobalt nitrate is given. PB nitrate is given, and lead nitrate is given. The blue color solution only given by the A option. And PB nitrate doesn't give the blue color, but it will give the brown ring test. PB nitrite so doesn't give the brown ring test. Nitrate, cobalt nitrate will give the brown ring test, but so not blue color solution. Cupric nitrate is the most. A is the correct option. Now question number 17. The question number 17. So what is there are four options are given. 1, 2, 3 compounds are given here. Which among the above compounds does not or do not form silver mirror? So when treated with this Tollens reagent. What is a Tollens reagent? Tollens reagent is that AgNH3 taken twice, so plus OH hydroxide alkali means so ammonical silver nitrate solution. This is ammonical silver nitrate solution, and aqueous solution of ammonical silver nitrate solution. That means Ag plus ions present in that solution. This Tollens reagent useful to test aldehydes, not ketones. Useful to test, distinguish aldehydes and ketones, because aldehyde so convert Ag plus ions into metallic silver precipitate, not ketones. Ketones do not give this test. So here is first option, aldehyde functional group is there. So respond to the tolerance test, right? Which among the above compounds does not form silver mirror when treated with this tolerance reagent? First one will give. So convert Ag plus ions into Ag, metallic silver. And the second one is, so here is look at this structure here. What is given here is alcohol functional group is there and double bond is there, and here one lone pair comes back due to polarization, and the proton can be, so tautomerism will takes place here because the pi bond will move to the here negative charge, so we can write like this. There is a pi bond here, so here is the OH, polar bond is here, and when lone pair come back to this between oxygen and carbon, there is a delocalization here, negative charge will form. Then the proton shift takes place here by using the tautomerization process takes place here. Then the sigma bond is converted to lone pair here. So the structure we can get is that ketone is formed here. Ketone is formation taking place. Since due to the tautomerization, the second compound doesn't react with the tolerance reagent. So, and in other case, what you can see here is here also then lone pair. When lone pair comes back here due to polarization, then this pi bond can shift inside. So if the pi bond can shift inside of the ring, then hydrogen comes here. So then so property. So then this also will give the tolerance test. And here tautomerism also possible in this compound when this lone pair move back, lone pair, so moving back between this oxygen and carbon, lone pair is moving, then hydrogen shift will be taking place. So this oxygen, right? So hydrogen shift will be taking place here. Then here is aldehyde functional group, here is the alcohol, and this also will respond to the tolerance test. Tolerance test is possible in this also. So, and the right option is second only. Second only, C is the correct answer. Now, 18th question, if you see given below two statements, one is labeled as assertion, other is labeled as reason. The sharp glass edge becomes smooth on heating up to its melting point. This is true. And the viscosity of glass decreases on melting. So, viscosity of the glass decreases on melting. So viscosity of the glass decreases on melting. Choose the most appropriate answer from the options below. So A is true, A is true, and R is false. So viscosity of glass decreases. No. So R is also right, but not correct explanation. Not correct explanation. So both R and true, but R is not correct explanation. So B is right option. B is right option. 18th question. Now let us move for the 19th question. The correct structure of Reuman's purple, the compound formed by in the reaction of ninhydrin, so with the protein. So with the protein is, so the protein is ninhydrin. Ninhydrin formula is, sorry. This is non-hydrogen structure. OH plus NH2, NH2, C. Here is COOH, R here. Here is hydrogen. This is that amino acid. Amino acid it is. So, and forms the compound is water. Water is removed. When water is removed, what happens means the nitrogen connect to this carbon. Condensation process. Here is this carbon is connected to nitrogen with a double bond. Then COOH, COOH. Again in the presence of one more anhydride. So we will get the compound is, so which is the most appropriate one is, so B is the most appropriate answer. B is the most appropriate answer. Anhydride. So we can get the compound is this is the final structure we can get. So because of anhydride double bond, so carbon with nitrogen double bond, so it will give the color, the purple color it can give. Right, so this is that question, and the last question in this paper is that 20th question. The 20th question, the correct order of intensity of colors and compounds is, so here is nickel tetrachloronickelate -2 and nickel hexa aqua nickel, so +2 charge, and nickel tetracyanonickelate -2. So here is high spin lone pair, unpaired electrons are present in this, and in this also high spin electrons also present, and in this low spin it is, so no unpaired electrons. No unpaired electrons in this. So unpaired electrons, the intensity color, this is the weak ligand, this is neutral ligand, this is strong ligand order. So intensity order will be first option. This is based on that unpaired electrons. So observe the spectrum. More are the unpaired electrons, more will be that intensity of the color. We can determine based on this option. Right. So these are the answers. So in this paper, and